Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student having to do with rectangular and polar forms, or I should say rectangular and trigonometric forms of complex numbers. So the problem is starting off with this notation for Z1 and Z2. So for Z1, she has 1/2 cis pi over 3. I just think it's easier to work with it. It's also trigonometric rotation, but a trigonometric notation, but it's, I think, easier to write it as 1/2 cosine pi over 3 plus I sine pi over 3. And then Z2 would be, it's been given to us as 3 times the cosine pi over 6 plus I sine pi over 6. I think just getting rid of that cis notation is going to make life easier for us. So we have this trigonometric form of Z1 over here, and then the same trigonometric form of Z2. Otherwise, it just makes it harder. So if we want the product Z1, Z2, is going to be 1/2 times 3, so 3/2 cosine let me put bracket around here. So you add the constants, then you add the angles. So it's pi over 3 plus pi over 6, like that, plus I sine pi over 3 plus pi over 6. So that's the product. And we can simplify that product. 3/2. Now pi over 3 is the same as 2 pi over 6. So it's 2 pi over 6 plus 1 pi over 6. And that is 3 pi over 6. 3 pi over 6 is the same as pi over 2. And that would be the trigonometric form of the product. Now, if we want this in rectangular form, obviously, which they're not asking for, but if they wanted, because they are asking about rectangular form, I'm not sure exactly what rectangular forms they want from the question, but this would just be 3/2. Cosine of pi over 2 is 0, so it's going to be 0 plus I sine of pi over 2 is 1. So that's all it is. It's going to be 3/2 I. Now, if we wanted to do all of this in rectangular form all the way through, you could start by converting each one of these to rectangular form, and then you can multiply them in the usual way. I'm not really sure if that's what the question is asking us to do, the product and the rectangular form for the problem. So I don't know, but I guess we'll just go ahead and do it. So Z1 here is going to be 1/2 cosine of pi over 3 is 1/2 plus I. The sine of pi over 3 is √3 over 2. And then Z2, well, actually, let's just distribute that half. So you're going to get 1/4 plus I square root of 3 over 4. For Z2, it's going to be 3 times the cosine of pi over 6. The cosine of pi over 6 is √3 over 2. Plus I sine of pi over 6. Sine of pi over 6 is 1/2. So let me just erase that. Just put a 1/2 here. And when you distribute the 3, you're going to get 3 √3 over 2 plus 3/2 I times 3/2. If you multiply these together, you're just going to FOIL them out. Three √3 over 2 plus I times 3 over 2. Okay, so now we're just going to FOIL. So we'll distribute the 1/4. And this is, I guess, maybe the teachers wants to see all this work, because the point of this problem might be to show you how much easier it is to multiply complex numbers if you have them in trigonometric form. So that might be the point of this problem. So we'll distribute the 1/4. So it's 3 √3 over 8 plus, we put the 3/4 in, the 3/2 in front of the I, so it's going to be 3 over 8 I. Okay, now I'm going to distribute the I √3 over 4. Oh, so this is 3 times 3, it's going to be 9 I over 8. And when I go here, I'm going to get I squared, which is -1. So that's giving me the negative here. And this is going to be 3 √3 over 8. Okay, because I times I is negative, I squared is -1. So it's 3 √3 over 8, right? So you can see these disappear. And then we have 12. 9 and 3 is 12. I over 8. And that reduces to 6I. 4, 2 times 6 is 12, 2 times 4 is 8, and that reduces one more time to 3 pi over 2. So you can see you get the same answer either way. whether you stick with the trigonometric form and go all the way through those steps, or whether you use the more familiar rectangular form here, or standard form. Sorry, this is called standard form, not rectangular form. And so either way is going to work. Your next assignment is going to have you multiplying complex numbers that are more complicated, and you'll find that the more complicated the complex number becomes, the easier it is for you to do it in trigonometric form, thanks to a math genius named de Moivre, who lived in France in the 18th century France. And so that'll be the next step in your journey on this. And I hope this solution here was helpful to you. I'll see you again next. I'll see you whenever you post another question. Take care. Bye-bye.